this kind of thing easier. I think the most complicated part of this homework was the diagram itself.
To use a homework task, you have to like do it and then turn it in. Yeah.
All right, so we're looking at number 5. So number 5 involves angles 3 and 4. So what I'm going to do is I'm going to draw my picture, but I'm not going to draw everything. I'm going to draw that part of the diagram that I need literally for angles 3 and angle 4. And then it's not so complicated to see. Fair? All right, if you see a box here, what does this box mean? Right angle. If this is a right angle, what's this angle over here? And what's this angle down here? And this angle over here. All right. If this is a right angle, what do you know about 4 and 3? So part A means that you should have identified them as complementary angles. Then part B, by identifying these, then you have to say, what do I know about complementary angles? And Hale said that they add to 90. And then it's this statement that allows you to write the correct equation. Let me put in what we've got. We've got angle 4 to be x minus 5. This helps also to put your algebra in the picture. So this tells me to add to 90, so I'm going to take my x minus 5 plus my 5x minus 13, set it equal to 180. Yeah, I'm thinking that's not right. All right, we're going to set it equal to 90. All right, so we've got x, we've got 5x. They're on the same side of the equal sign, so we combine those. We've got negative 5, we've got negative 13, so we're going to have negative 18. So now you're going to add 18 to both sides. This is where I missed it. I subtracted 18. 6x is equal to 108. Now you're going to divide by 6, and you're going to get x to be 18. Now, the next question is, what am I asking for? And I really think that the EOC will not stop here, that they're going to go further. All right? So find the measure of angle 2. So now I'm going to take this line, and I'm going to extend it because my angle 2 happens to be right here. So this 2 has got to be related either to 3 or to 4. So if I trace the sides of 2 and here, what type of angles are 2 and 4, Brittany? What kind of angles are 2 and 4? They're vertical. What do you know about vertical angles?
They're equal.
That they're equal. So if 2 is equal to 4, are you prepared to find the measure of angle 4?
Pretty much.
So we're going to say measure of angle 4 is equal to 18 minus 5, which is 13. And because the measure of angle 2 is equal to angle 4, it's also equal to 13. Madison.
How do you know it's minus?
Say that again.
Yes,
Because they asked me for 2, and this relationship is vertical, so it's equal. If the relationship had been complementary, then I would have subtracted.
not vertical.
It could be something else. Are you talking about like number 6?
Yeah.
Okay. So I think this might. We're going to go over 6. Pardon? Over there. All right. So we're going to go over number 6. Not at the moment. I'm going over number 6. All right. So I'm going to draw only that part that I need. I need DBA. So that involves this, and that involves this segment. So let me label this. This is A, this is B, and this is D. So do you see angle DBA? They told us DBA was x plus 17. Then they're saying CBD, here's C, CBD happens to be 2x plus 1. So without all those other stuff in that picture, you can see that, what's this relationship, Maria?
Sorry.
What kind of angles are these?
They're equal to 180.
Okay, but what type of angles? You have to be.
Supplementary.
Okay, that's the relationship. They are.
They're equal to 180.
They're a linear
Linear angles.
pair. And then they're going to add to what? Add to 180. So now this tells you what you're supposed to do with them. What are you supposed to do with them? What equation do you write?
X plus 17 plus 2x plus 1.
Exactly. All right, plus 1 equals 180. So we're going to end up with 3x plus 18 equals 180. So we've got 3x is equal to 162. So x is going to equal 54. So now what did they ask for? They asked for angle CBE. CB, well, now I need to find E. And I believe E is this little side extended. So we've got an E down here. So we've got C, B, E. No, B is a point. All right. So I'm going to highlight this angle, angle CBE. And if I trace this out, what's the relation? You could do this several ways. What's this relationship right here? Vertical. What do we know about vertical? They are equal. So I could say, all right, since they're vertical, that I know that this is also x plus 17. So the measure of angle CBE is equal to 54 plus 17, or 71. Now, another thing you could have done is you could have said, well, look, this is a straight line. So this angle plus this angle that I do not know is equal to 180. So if you had not seen the vertical relationship, and this goes to answer your question, Madison, could you have put 54 here? You've gotten 104. 2 times 5 is 8. Be 108. Plus 1 is 109. So if you get this to be 109 and you know this is a straight angle, how do we get this angle then? What's the relationship when you have a... So if I said 180 minus 109, guess what I'm going to get? 71. You thought what? Yes, but notice I came to it another way.
Where'd you get the E from? Oh, I see it. Her head was
Okay, so we know these add to 180, so if I know this one, I can subtract from 180 and get that one. That's one way to do it. Or I could recognize the vertical and do it with equals. Wendy? Okay, this is the deal. A right angle is 1 angle equals 90, where complementary is the sum of 2 angles equal 90. Very different. Brian, thank you for raising your hand. Complementary is defined as 2, but if you knew that you had this perpendicular relationship here and there were 3 angles there, yes, they would all add to 90 by angle addition. Okay? Any other questions on the homework? Problem 1. We have 1. Okay, so let me go down. So now this is question 1. I'm going to draw on my picture all that I need. Madison? Okay? So we've got angle 4 and angle 2. So I think it looks like this. And literally, I could get rid of that. This is angle 4. This is angle 2. So if angle 2 is 4x plus 3, and angle 4 is 7x minus 21, what type of angles first are these, Madison? They're vertical. Next, what is their relationship? They equal each other. So what equation do you write? Right. And now you're going to solve. I'm going to subtract 4x. I'm going to add 21. And x is going to be 8. All right. So now they're going to ask you for the measure of angle 3. So now I need to put this back in because 3 happens to be right here. Now, if this had a box, that means this is 90, making this what? Okay, we don't know what 3 is. We don't know what this angle is, but we know 3 and 4 are related how, Madison? They equal 90. So I'm going to be able to find measure of angle 4. So measure of angle 4 is going to be 7 times 8 minus 21. They are, but I have to find 4 to get 3. Okay, so 56 subtract 21 is going to be 35. So now if 4 is 35, how do we find the measure of angle 3? What? Divide? So we're going to say 90 minus 35, and that's where we got 55. Well, I can't say that because it could be a supplementary relationship. At which point you might have to subtract from 180.
Unless it's that.
Right. All right. Right now I want you to take out a piece. What's your question, Trevor?
What are we going over?
The homework that you didn't do because you were absent.
Okay, so then what do I do?
The homework that we had on Friday. And we just talked before class about where you find what you missed.
I need to turn in the homework for Thursday.
You can do that when everybody else turns in their Fridays. I need you to get out a sheet of patty paper. I need you to get out straight edge. I gave you bunches of patty paper. Oh yeah, and I'll give you a bunch if you remind me after class. All right. Shh. All right, we're switching gears just for a minute. I would take notes on a sheet of paper and then paste your pad or tape your patty paper to that sheet of paper. Before we get too far, perpendicular lines are lines.
We don't see that.
Are line. Thank you, because I always forget. All right, perpendicular lines are lines that form right angles. Perpendicular lines are lines that form right angles. So if you are told perpendicular, the way you mark it is with this box. So that's the marking for perpendicular. Unless that box is there, I don't know, I don't care how perpendicular the lines appear. Without that box, you cannot assume 90-degree angles.
Wait, what's that? Like, upside down T?
We're going to talk about that. So are you with me on the box? All right. So now, you know mathematicians are inherently lazy and we don't like to write out words. So everything that we can abbreviate, we do, and we do it with symbols. Does that look like perpendicular lines? Are you kidding me? That looks like a little set of perpendicular lines. So if I want to describe two lines being perpendicular, this is what you will see. Segment AB perpendicular to CD. Maria. This is section 5.2. Or it might be called 163652. It's a combination of 3 sections. So AB perpendicular to CD. That's what that little upside down T means. That says the word perpendicular. Yes. Correct, but they weren't on your worksheet. All right, now to draw, label, and mark perpendicular lines A, B, and CD. All right, this is so important to be able to draw, label, and mark. There's one segment. There's my other segment. That's the draw part. The label would be A, B. Now, I could have extended that if I wanted to. There's C, D. That's the label part, and the mark is putting that box there to show the perpendicular. So when you're given perpendicular lines, I want you to immediately think what? Do you think? 90. I'm not writing that very well. Let me erase that. I want you to immediately think 90-degree angles, and I want you to look for them.
Is this going to be at the test tomorrow?
No, just what I've got written up there. All right. Now this is going to help you on the word map. You're going to have two word maps. I want you to do perpendicular word map and the perpendicular bisector word map. So I will collect those because I'm assigning them. So I want perpendicular line word map and I want perpendicular bisector word map. And I want them well done. I'm not going to give you credit if it doesn't make sense or if it's sloppy and you did it in a second. All right. So here's the word map. It's in the notes. It's online in the PDF. You're going to define it in your own words. You're going to explain how to draw, label, mark. You're going to tell me what do perpendicular lines form and what you're going to look for.
Do perpendicular, does it equal one whole angle or is it two angles?
Perpendicular lines form right angles. So if they intersect if they intersect like this, they're going to form 4 right angles. If they intersect like this, they're going to form 2 right angles.
Okay, so it's never just one angle?
It's never one angle. There will always be a minimum of 2 on the notes. No, it is like the 1, 6, 3, 6, 5, 2 notes. It's several sections together. Okay. So now, perpendicular bisector. If you look, this word is made up of 2 pieces. It's made up of the word perpendicular, and it's made up of the word bisector. So we got perpendicular bisector of a segment. So what do you think this is going to do? Excellent. Perpendicular bisector of a segment is a line that forms right angles with the segment, and what else? What does a bisect mean? And forms 2 congruent or equal segments. All right. So perpendicular bisector, I love to give you because in those few words, I've just created a whole mess of things that we can work with. So this perpendicular bisector deal comes with additional markings. So if I told you again that AB is perpendicular to CD, you should show me a right angle for the perpendicular, but what do you show me now for the bisects? The congruent marks, because we already did the 90. So now, when you're given a perpendicular bisector, what do I want you to think? Two equal parts, meaning segments, and what else? That's the bisects. Do the perpendicular. 90-degree angles. So that's going to help you on your perpendicular bisector word map, Brian. Perpendicular bisector does 2 things. The line forms right angles with the segment, and it forms 2 congruent segments. So these 2 segments are congruent because the bisect, and these lines form right angles because of the perpendicular. Okay? All right, so these notes will probably be in 2 parts because I think I'm going to pause this and then I'm going to have to